Okay, this video is a review of the four types of equations that we're going to be solving equations for, where you'll be given a set of data and you have to come up with an equation. I'm going to do the steps to solve the problems, but I'm not going to do the arithmetic at the necessarily at the end of each type, but we're going to start with the first part right now. So we are going to start with linear functions. And linear functions will either just increase or just decrease. They have no concavity. The general equation for a line equals y equals mx plus b. And we need to solve, to know the equation, I need to know the m, and I need to know the b. So there's two things, which means I need 2 points, 7, 4, 9, 10. To solve those, I can put them in a matrix. What I normally do is set them both matrices up. And I will substitute the x's and the y's into this equation. So this becomes 4 equals 7m plus b, and 10 equals 9m plus b. You might want to write your equal to on the other side. Doesn't matter to me which way you do it. And then we'll sub in the coefficients into the first matrix. The missing letters into the next one, M and B. And then the answers in here, 4 and 10. So the short way of thinking about that is it's always going to be x1, x2, 1, 1. And then we're going to have the matrix y1, y2. And into the calculator, we'll do the inverse of the first matrix times the last. So remember, what we're doing is we're taking this matrix here, doing the inverse of it, multiplying it by that function, and we will have the answer, we'll have the m and b for our linear equation. They're either concave down like that curve, or concave up like that curve. Their general equation is y equals ax squared plus bx plus c. In order to solve the equation, I need to find a, b, and c. So because I have 3 values I got to find, I'll need 3 points. So let's erase this picture right here, and let's put a quadratic on there. It's the only one that's going to have the turning point. There was a fly on my page right there. So let's say we know we have the points 2, 9. We have 3, 3, and we have 6, 10. So I'm going to take my points and fill them in, the x's into the equation and the y's into the equation. So I'll start with, doesn't matter which points I use first, I'm going to put 10 equals 36a. Why 36? Well, I squared the 6. Plus 6b plus c. 3 equals 9a plus 3b plus c. And 9 equals 4a plus 3b plus c. If you want to think about it the easy way, it's just the x values go in the middle column and the square of the x values go here. And these ones will always be 1. So now I'm going to enter them into the two matrices I need. So it'll be 36, 6, 1, 9, 3, 1. And I don't know what happened there, why that turned into a 3. So Sarah, if you found it before I did take your dollar, that should be a 2. And it should be, it should be 4, 2, 1. There we go. Inverse of that times 10, 3, and 9 is going to give us back our a value, our b value, and our c value. On to the next type. Next we'll have our power functions. Our power functions will either pass through the origin or not touch the axis at all. They can look like this. If it passes through the y-axis at all, it's no good, but it can touch at the origin. The general equation for a power function is y equals ax to the b. In order to solve, we need a and b, so we need two total points. Let's pick 2 points here. Let's go with 1, 5, and let's go with the point 2, 8. And to solve those out, I'm going to fill in the x's and y's into the equation. I'll get 8 equals a times 2 to the b. And the second equation is 5 equals a times 1 to the b. Now there's a technique we do to solve one of the variables. We don't use matrices on these. We're going to divide these two equations so that the a's cancel out. And I'll have 8/5 equals 2b over 1b, which actually simplifies, because 8/5 equals 2 over 1, all of that to the b. So I'm going to simplify it down a little more. It becomes 1.6 equals 2 to the b. And now we used our introduction into logs. If you can't solve a problem that's in exponential form, the easiest thing to do is convert it into log form. So to convert into log form, I write the word log. This is going to be the same equation, just in a different form. The base is 2. And the exponent goes all the way by itself. So I've got log, I wrote that 2 way too high, didn't I? I know I did. Log base 2. And then I fill whatever number I've left in, right there, 1.6. So remember what I did was I found the base, put it next to the log, and I put the b all the way over by itself. Now I can use my calculator to solve for b. And I have found that b is equal to 0.68 rounded. So I've solved for b. Now to solve for a, I'm going to put that piece of information back into any one equation. So I'm going to erase a little space here, so I have some space to work. So I went ahead and grabbed this equation. I substituted the 0.68 in for b, and I solved and found that a was equal to 5. So my final equation is the following: y equals 5x to the 0.68. So that should be the equation, the power function that contains those points. Well, what I've done to prove that's the case is I'm going to show you what I put in my calculator. I took that function and graphed it. And here's a picture of it recorded. I put in 5 times x to the 0.68, and I graphed it. And then what I did was I used menu 51 to trace, and I typed in the number 1, and there's the first value that's on the graph, 1, 5. And then I did that again. I did menu 51 for the value at, and you can see when I put in the value 2, I got 8.01, so it was obviously a little bit off, but that's because I had to round the 0.68 to begin with in the problem. Okay, on to the next type. Okay, the next type is exponential, and the exponential functions are going to pass through at some point the y-axis. The general equation for an exponential is y equals ab to the x, where the x is in the exponent. They're actually easier, I think, to solve than the power functions. There's one thing that makes your life easy if you do it. If you just remember this, please, please, please make sure you put the biggest x on top. You're not going to get it wrong if you don't, but it makes life a lot easier. So I have this exponential function which passes through the y-axis. I'm going to fill the x's and y's into the equation. But I'm going to make sure the biggest x is in the top equation. So I know 2 is the biggest x, so I'm going to write b to the 2 times a equals 24. B to the 1 times a equals 48. And just like in the last thing, I want to cancel the a's out, so I'm going to divide the two equations. The a's are gone. I've got 24 over 48, which is equal to 1/2, or 0.5. Doesn't matter what you do. I'll write 0.5. Equals b squared over b to the first. Now, this will happen on every one of them, but the numbers may be different. You'll be able to cancel out the ones on the bottom with some of the ones on the top. I got 0.5 equals b. I've now solved for b. Hey, good job by me. All right, so now that I've got b, I can put it back into either equation. Let's do into this equation. And find a. So I've got 48 equals a times 0.5 to the first. So to get a by itself, I'm going to do 0.5 to the first power, divide by 0.5, and I'm going to get, which is equal to 96. So my equation for this graph is going to be y equals 96 times, usually write parentheses just so we know that that's there, 0.5 to the x. But just so you know, I did exactly what I did in the last problem. I graphed this, and I made sure the points matched on up. So that's your video for tonight. You have 2 questions you can answer to me, either via Remind or via text. The first question is the following. So there's your first question. If you don't have your packet with you right now while you're watching the video, you can text that to me right now, and then you can tell me which ones they were in class tomorrow. And the second question is, and there's your next question to answer. The choice is one of the 2. You can just text that information over to me. Okay, folks, I'll see you in class tomorrow. Goodbye.